Thank you very much for introduction and for everyone's coming to my presentation today. I'm Shusei Tomonaga. Our presentation today is about how attackers spread the infection in the network and some tips that may help such analyzing lateral movement, which we published in a report last year. Sorry. First of all, let me introduce ourselves. My name is Shusei Tomonaga. I have been working as a JP-SAT Analyst Center for 5 years. My primary responsibility are to analyze malware and DFIR. We have been publishing analysis observation on our blog. We are also developed some tools which are useful for malware analysis. These are available on GitHub.
And just quickly let me introduce myself. My name is Keisuke Muda, and I'm an analyst at Security Operations Center at IAJ and Eastern Japanese ISP. And as a member of IAJ SOC, I'm primarily working on the analysis of logs sent from customers' networks and researching analysis of software vulnerabilities and enhancement of IAJ SOC service and service infrastructure. So why I'm here is because I've worked on the report I'm going to show you later with Shusei for this.
So before I get into main topics, I would like to talk about some issues in DFIR at APT incident. First, many hosts need to be investigated at APT incident response. Attacker that has intruded into a network usually infect in many hosts and server, spread the infection within the network. For investigating such hosts, we obviously need logs. However, logs required for investigation are not always recorded. Therefore, it is often difficult to detect or investigate lateral movement. In this presentation, we will introduce our approach to those challenges. Through the analysis, we have found a limited set of tools are used in many different incidents for lateral movement. So if you know what log will be acquired with our tools, investigation process will be smoothly. This is today's presentation topics. We will talk about overview of APT incident and lateral movement, and typical tools used by attackers. Finally, I will introduce some techniques for tracking lateral movement. First, research of lateral movement. We examined the tools used by the attacker. For this research, we use a disk image of the CNC server and decoded malware connection. Forensic investigated disk image is APT10, APT17, Dragon OK, Blue Termites, and Tick. These campaigns targeted at Japanese organizations. This is an example of the list of the files in a C2 server that Blue Termite was using. Malware names this status was managed by IIS and Access Database. Another example, malware names MDB was managed by PHP and SQLite database. And executed command by the attacker was saved in the database. We examined the command executed by the attacker from the server of C2. Total command execution is 60,866. As a result of analyzing the corrected command, I found an interesting fact. We found that 84% of the command executed by the attacker are the Windows command. These are many control commands for malware, but attackers tend to use Windows command. Attacker use not only attack tools but also Windows command and legitimate tools. Why do attacker use Windows command and legitimate tools? Because they are not detected by antivirus software. Next, let me introduce the tools that attacker use for lateral movement. This slide introduces the flow of APT incident. An attacker who infected the host with malware collects information on the host. Next, they collect information of other host and server within the network. And they spread the infection to other hosts. They will send confidential information using cloud service and so on. Last, they delete logs and created files. Lateral movement has 4 steps: initial investigation, internal recon, spread of infection, and delete evidence. After this slide, I will describe what kind of tools are used in the 4 steps of lateral movement. So first step is initial investigation. The most used command is task list. If an attacker is not interested in an infected host or realize the malware is running in a sandbox, they will escape soon. This table summarizes the Windows command executed by the attacker at this stage. Attacker uses task list, var is version, IP config, system info, who am I, and so on. Second step is internal recon. The most used command is dir. The attacker looks around confidential information stored in the infected host. For searching the network, net command option is used. An attacker investigates confidential data using dir and type command. And to search domain network, net command options are used. So ping and echo command are also often executed. So net command is a powerful tool that many attackers use. Net command can investigate various information of domain network. We found that attackers use commands such as ping at this stage. Why ping command is often executed? The reason for this is simple. They use ping command to search in a local network. Another common command used by attacker is echo. Why echo command is executed? Because they use echo command to create script files. They are often created with the echo command rather than downloading a script file. This is a quantitation of the details. Dump EL and log parser are not installed by default Windows. These commands analyze the event log created by Microsoft. Attackers are collecting a list of users who log on using these commands. Third step is spread of infection. The most used command is AT command. Attackers use AT command to execute the command on the remote host. AT command is not supported on Windows 10 and Windows 8. If AT command cannot be used at the environment, we found that SCH tasks is used. WMIC is another method of remote command execution. Attacker use move, copy, and reg command to install malware on the host. Here is an example of the AT command and SH tasks. Attacker use net use command to map a remote host with network share. After that, use AT command and SH tasks to execute malware. WMIC can be used even without connection to a remote host. And WMIC is also used to investigate Windows information. Another example of installing malware, by using the mofcomp command, attacker can register WMI command to repository so that a command can be executed periodically. Fourth step is delete evidence. The most used command is delete command. In a few cases, they use wbt util to delete the event log. They also use delete, task kill, klist, and wbt util command. In addition to deleting event log, wbt util can search them. This example is searching log on event ID. Another example of the delete evidence, they remove ticket of past ticket. Recently, pass hash is not used for malicious logon. They tend to use pass tickets such as golden ticket and silver ticket instead. Attacker can delete these tickets by using the klist command. So this is an example of the lateral movement steps executed by the tick attackers. The first initial investigation is who am I command. Then use mimikatz to create a golden ticket. Internal recon use the ping and dir command. They execute the file to remote host with copy and AT command, and finally delete the files.
Okay, up to here, Shusei has talked about the tools used by attackers. And, well, attackers use the tools, so we need to figure out how we can actually trace those attacks. And regarding about tracing the attacks, if the Windows is not configured, it's out of box on default, then what works are taken on Windows? If it's a client OS, it's successful and failed logons, and successful logoffs, and successful policy modifications. Those are recorded on Windows logs by default, but that's about it. And if it's a server OS, the authentication is also recorded on Windows, but still not many that logs. So some of the logon histories could be traced from the default logs, but there may not be enough record to prove other activities, such as programs being executed or files and networks being accessed. So what we can infer from that is default configuration is not enough. So we need methods to cover the missing pieces. And if you take a look around, there are not so many documents that summarize those methods and significant points for identifying threats. Well, we know that some of the entities are not recorded on Windows by default, but it is possible to configure host to keep those records. So we do need to think about which entities we should cover to track the attacks. So what have we done in past several years is we've analyzed them. So we've taken the tools and commands that were used in actual attacks, and we've selected 49 tools that were frequently used in attack behaviors. And about 1/3 of them were actually legitimate Windows tools, the default Windows commands in those. And we've tested them, each of them, on a virtual network. And we've logged the records of the executions, and we've analyzed them. And the result we came up for the analysis is, in most cases, additional tweaks were necessary on Windows to obtain enough records. And we put them together and published it as a research report. And it's on JP-CC website, and I'm going to put the URL later at the very end of this presentation, so you can take a look at this. And we studied this in Japanese, but it's in English also, so you all can read this. So what we have on this report is it shows some important aspects for tracing each of these tools. And we have the tables and lists of the entities that we've taken a look. And what elements did we research? One is the Windows event logs for both default and additional logs, and the registries, and cache for performance improvements, and file system activities, and file and folder access histories, and network traffics. And among these elements, the result we came up is event logs was the most useful. And when I say event logs in this presentation, it means the audit policies and Sysmons and application logs. And there are also some other useful information, and the two I'm going to pick up in this presentation are the USN journals and packet captures. So knowing that, I'm going to show the example analysis of tools used by attackers. And the one I'm going to pick up here is the PSExec. How many of you know what the PSExec is? Can you raise your hand? Oh, many of you. Yeah, it's very common thing, right, for many of us. And it's a legitimate tool, and it's part of Microsoft Sys internals. And what it does is it executes a specified program on remote host. And it was intended for the system administrators to run the commands on remote computer, so they don't have to actually go to the computer. But we know that sometimes it is used by attackers in malicious ways. So if PSExec was executed, what can we find out from the default Windows is the target host. When I say target host, that means that's where the program is executed remotely. And on a target host, the installation, execution, and termination of PSExec SVC, that's the service for handling the PSExec. That remains as a record on the event logs. And the source host, that's where the PSExec was originally executed. There are two things that might remain as a record. The one thing is the prefetch. And if prefetch is enabled on the host, then prefetch file remains on the prefetch folder under the Windows directory. But prefetch is not always enabled. If it's a Windows server or Windows clients under certain conditions, such as virtual machines, then prefetch may not be available by default. And other things that might remain on the source host is when you execute the PSExec for the very first time, you're going to see the dialog saying, do you accept the license agreement? And if you say yes to this, then the record of saying yes remains on the registry. So that would be another thing that would remain on the source host. But again, if PSExec has been used on that host in the past, then it won't help. So we need something to figure out the execution of the PSExec. And this is an example of showing the PSExec being executed on the target host. It says the PSExec SVC service enters running state. Okay. We can see that PSExec was executed, but we aren't sure about specifically what happened. So we need to know more about the incident to figure out what happened within the attack. So where do we start from? Well, let's start with audit policies. Why is that? Because it's an option available on Windows by default. And if you take a look at the audit policies, not so many events are actually audited. So which results us to the lack of the evidences for tracing the attacks. So we should enable them. Well, which one should we enable? Start with the process creation termination. So if you decide to audit the process creation on the auditing policies, what you can see for being the PSEXEC being executed is you can see the PSEXE svc.exe being executed, and the token elevation type was type 1 or 1936, which means the 4 in this token robustness. And the other thing you can find out from this, the process creation logs, is, and this is an example of being PowerShell executed over the PSEXEC. So you can see the PowerShell executed, and its parent process was the PSEXE svc. Okay, but many of us know that PowerShell can do hundreds of things, so it's still not enough. Still not sure about what has happened, so we need to do something. So what we came up next is to use the Sysmon. And how many of you know what the Sysmon is? Can I see the hands? Many of us, okay? It's a software that's part of the Microsoft Sys internals, and it's publicly available on the Microsoft website. So if you take a look at the audit policies and Sysmons, some of the properties might be common in both logs. But as far as we've taken a look, the Sysmon logs tend to have more useful details. For example, Sysmon logs records the hash values and command lines and parent command lines and other details by default. And one other good thing about Sysmon is it's getting updated very frequently. So one of the things they've added in the recent version is they've added the application descriptions and versions on which you can see on the properties for the executable files. So Sysmon sounds good. But Sysmon is not perfect because some properties, such as token elevation types, which I've mentioned earlier, they appear only on audit logs. Okay, so that's audit and Sysmon. Well, what about the registry events? Well, registry events can be recorded on both audit and Sysmon logs also. But Sysmon tracks the process creation and termination by default, but it doesn't record the registry activities by default. So either using the audit logs or Sysmon logs, you do need to configure them to record the registry events. And regarding the file access, and when I say file access, it means file systems and the network shares. And access to the file shares and access to the file systems can be tracked using the audit logs. And if you are just talking about the file creation, it also can be logged with the Sysmon, and Sysmon logs are actually easier to read. But again, you need to configure the Sysmon to record those file activities, and it doesn't track the modification or deletion of files at the versions they've posted. So regarding the file audits, probably using the auditing policy would be better. And another thing we can talk about here is the network connection. The network connection is another example that can be audited with both audit policies and Sysmons. And they both have the similar contents, and from our opinion, the Sysmon would be easier to read for us. So we've talked about some logs can be taken on both audit logs and Sysmon, and some logs can be taken on audits and those. So which one should we use? Well, actually use both of them. Why is that? Because there are both pros and cons for using audit policies and Sysmons. The pros for using the audit policy is it's available on Windows by default, and some information are logged on audit logs only. But cons for using the audit policy is first, some logs are confusing. You have to be familiar with handles for file system activities and bindings on the Windows filtering platform, that's the Windows firewall. And another cons for using the audit logs is it may have fewer details than Sysmon in some cases. So, but the pros for using Sysmon is it's relatively easier to read, and it has some more details such as file hashes and command lines. And cons for using Sysmon is first you need to install software, and that's probably not easy sometimes, especially in large enterprises. And another cons for using Sysmon is additional settings are necessary in some cases. And when you want to make a changes to Sysmon configuration, you need to make an XML file and import it. But that's sometimes difficult. So up to here, I've talked about audit policies and Sysmons. Next thing I'm going to talk about is application logs. And application logs is also available on the event view. And the other example I can bring up here is, again, the PowerShell. By default, the execution of a PowerShell is logged. But what it says here is PowerShell console is starting up, or PowerShell is ready for user input. But yeah, it's ready for input, but what happened in PowerShell, we don't know yet. So we need to configure the PowerShell to get logs. And if we configure the group policies, it is possible to configure the Windows to record PowerShell logs. And it's available on Windows 10 by default. And if it's an older version of Windows, you have to install additional modules for this. And if we enable the logs for PowerShells, what we can get are the entire script being recorded in an event log, and also the command histories recorded as a separate text file. So if you enable the command history, there are two types of the text log for the PowerShells, and one is the command history, that's the list of the commands executed on PowerShell, and another one is a transcript, which is the command and output on the terminal. So the default settings does not provide sufficient logs for tracking PowerShell scripts, but if we configure them appropriately, then it becomes possible to retrieve some logs for script executions. And there are many other application logs, not just PowerShell, that are useful for tracking attacks. And the examples we've raised up on our report are WinRM, WinRS, and terminal services or remote desktop. So logs sounds good. You know, it's very good. So what we have no idea about which logs we should keep. So simply just keep every single log. That sometimes happens when you design systems. But if they take everything and filter out later, it's the policy, then it's okay to keep everything. But it's not always a smart idea. Why is that? Because by default, all logs are overwritten when a log reaches its maximum size. And what are the maximum sizes for the event logs? Well, if it's a domain controller, the security logs, that's where all the audit logs are recorded. The maximum size is 128 megabytes. And for the logs for the other hosts, the clients and Windows servers that are not the domain controllers, it will be 20 megabytes. And other logs, the application logs, the default size varies for each type of the logs. So it is important to configure the log sizes because logs for several weeks are stored without making any of the additional settings I've talked about so far, but it doesn't contain enough evidences for tracing attacks. And logs might get overwritten within few hours with improperly configured additional settings. So we do need to be careful about the log sizings. So up to here, I've talked about the event logs. And for the rest of the presentation, I'm going to quickly speak about the two other additional useful information, the USM journals and packet captures. The USM journals, when files are created, deleted, or modified on an NTFS file system, USM journal is recorded. And it looks like this when you export it to a text file. And audit logs can keep track of file creation and deletion, but sometimes the audit logs may not be available, like the logs getting overwritten or the logs getting erased and those. And USM journals could also be useful for tracking the file creation and deletion. And one last thing I bring up here is the packet captures. And PSExec uses the SMB2. That's the protocol used on Windows for the many of the Windows communications and file sharing. And if you monitor this, the execution of PSExec can be monitored from the packet captures. So it's very small, so I'm going to make it bigger. If you see this, it says create request file, psexesvc.exe. That means to copy the PSExec service file from the source host to the target host. And the next thing says create request file svcctl. That's to start the PSExec service on the remote host. So from this, you can see the PS execs being executed. And oftentimes the attacker changes the name of the psexec.exe because it's obvious it's psexec. So attackers might change the name of this. But even if they change the names, this name, the psexe svc, may be still available on the packet captures. So it's worth looking. And another things that can be monitored on the packet captures are these std in, std out, and std error files. And those are requested over the SMB2, and they are actually the output of the PowerShell. So this is just an example. I mean the psexec. So this is just an example. But if the program uses the SMB2, oftentimes operations can be monitored through the packet captures. So I've talked about event logs and USN journals and packet captures. So why are we talking about the logs? Well, because it helps us illustrate the details of attacks for this. And if the attack created temporary files or registry values and then removed them, then it becomes hard to figure out their contents. And if the command line was not recorded at all, and it becomes hard to figure out what was done during the attack. So not just looking at the disk of the machines that was being attacked, but looking at the logs would be helpful. But as we all know, there are always challenges. So some of the challenges for looking at the logs is sometimes the additional logs will become necessary. And those additional logs could be the operation logs of client computers or EDR, or the network activity logs. And it is necessary to tune up log sizes appropriately, as I said earlier. The older logs might get overwritten when they get too large. And the last thing is the logs could be purged during the attack. So it may be necessary to keep live logs to a safe location using technologies such as the event subscription or installing the syslog daemons and those. So, as a conclusion, there are three things we wanted to point out in this presentation. One, typically limited set of tools and commands are used for lateral movement. Two, many attack tools can be detected with audit policies and Sysmon. And three, our report would be helpful if you are investigating the APT incidents. And that's it from us. That's the URL for our report. And thank you very much for listening.
Thank you very much. Does anyone have any questions? No? Okay. Thank you very much, guys.
Thank you very much.